Hello friends, I am Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. In the last session, we had discussed about the quadratic equations and we learned about when we are going to have the imaginary or the complex roots or the real roots, and we learned about our quadratic formula, and we also learned that how to determine a quadratic equation when the roots of the equation are already given. Apart from this, we learned if the quadratic equation is given to you, how to determine the roots of the equation. Now, it is time to extend our discussion to the concept of cubic and biquadratic equations, and in this session we will be exploring cubic and biquadratic equation. The objectives of the today's session are that in this session you will be able to understand the cubic equations, understand biquadratic equations, determine the solutions of cubic equations and solutions of the biquadratic equations. As we had already learned that there are different type of equations. We are having the linear equations, we are having the quadratic equations. On the same lines we are having the biquadratic equations also, and the terminology varies with the exponential power of x. Likewise, a x plus b equal to 0, a x square plus b x plus c equal to 0. Now, over here the power of x, the variable x is 1. That is why this equation is linear. The power of this variable x, the highest power of the variable x is 2 over here. That is why this is quadratic. And a quadratic equation is supposed to have two roots, that means two solutions, because the maximum power of variable x is 2. Over here there is only single solution because the maximum power of x is 1. Though this is to let you understand how roots and the exponential power of the equation are related. Now, that means in case of a cubic equation we are supposed to have 3 roots. That means a cubic equation is a polynomial equation in x, that is a variable in which the highest exponent is 3. Likewise, over here the highest exponent is 3, rest all are 2, 1 and 0, x to the power 0. So, that means this is a cubic equation. Similarly, a biquadratic equation is an equation whose highest exponent is 4. So, over here the highest exponent is 4, remaining all exponents are less than 4. So, that means this equation is a biquadratic equation. And again the next important thing is, likewise in the quadratic equation we also said that a should not be equal to 0, and over here a should not be equal to 0, a naught should not be equal to 0, because if this turns out to be 0 then it will turns out to be a cubic equation, and if this turns out to be 0 then it will be resolved to a quadratic equation. So, the conditions are that the coefficient of the x cube should not be 0 in cubic equation, and coefficient of x to the power 4 should not be 0 in biquadratic equation. Now, why it is called biquadratic? Because x square leads to quadratic equation and square of x square, that is equal to x to the power 4. So, that is why this is called biquadratic. This is called biquadratic equation. Now, without going into the details, likewise we perform the proof of determining that quadratic formula. We are directly using the relations for the roots and the coefficients of the cubic equation. Say alpha, beta and gamma are the roots of the cubic equation a naught x cube plus a1 x square plus a2 x plus a3 is equal to 0. You can always say a3 as a3 into x to the power 0, because anything raised to power 0 is 1. So, that is why then the flow you will be able to understand that in a polynomial the powers are moving a naught x cube plus a1 x square plus a2 x to the power 1 plus a3 x to the power 0 is equal to 0. So, this is nothing but a cubic equation. So, alpha plus beta, likewise in the quadratic equation alpha plus beta was minus b by a. So, alpha plus beta plus gamma, because it is a cubic equation. So, there are 3 roots alpha, beta and gamma. This will turn out to be minus of a1 upon a naught. What is a1? a1 is root of x square. Likewise in the quadratic equation, just for remembrance, ax square plus bx plus c equal to 0. What was alpha plus beta? Alpha plus beta was minus of b by a. And over here, if I say ax cube plus bx square plus cx plus d equal to 0, then alpha plus beta plus gamma is likewise over here coefficient of one term lower than the highest coefficient. So, 1. So, coefficient of x to the power 1. So, over here because the equation is cubic, coefficient of x square. So, that is minus of b by a, because a naught is coefficient of x cube. In quadratic equation, a was coefficient of x square, b was coefficient of x to the power 1. In cubic equation, b is coefficient of x square, a is coefficient of x cube. So, a1 is coefficient of x square, a naught is coefficient of x cube. So, minus of a1 by a naught will be equivalent to the sum of the roots of the cubic equation, that is coefficient of minus of coefficient of x square divided by coefficient of x cube. Similarly, in the quadratic equation we had alpha beta is equal to c by a. Now, on the same lines over here we will be having alpha beta plus beta gamma plus gamma alpha, and this turns out to be a2 upon a naught, that is nothing but coefficient of x upon x cube. Okay. So, that was you can understand, you can remember it just by understanding the simile between the quadratic equation and the cubic equation. And alpha beta gamma turns out to be constant term upon coefficient of x cube, which was over here alpha beta constant term and coefficient of x square. So, minus is also there. So, you are supposed to just to remember these formulas, that is alpha plus beta plus gamma is minus of a1 upon a naught, and again you can say that first a1 is there, then a2 is there, then a3 is there, and sign is changing, minus is there, then plus is there, then minus is there. This is simple way to remember that alpha plus beta plus gamma is minus a1 upon a naught, alpha beta plus beta gamma plus gamma alpha is a2 upon a naught. Now, the sign will change, minus to plus, alpha beta gamma will be a3 upon a naught, and now again the sign will change, minus. So, minus a3 upon a naught. So, this way, in this way you can remember that how these identities are. Now, similarly on the same lines you can understand for the biquadratic equation, that there is a relation in between the roots and coefficients of the biquadratic equation. Now, because this is a biquadratic equation, that means the exponential power is 4. So, that means there should be 4 roots, and the 4 roots are alpha, beta, gamma and delta. Now, so some of the roots alpha plus beta plus gamma plus delta again follow the same thing. Now, in this case you are supposed to first a1, then a2, then a3 and then a4. So, the numerator values are 1, 2, 3, 4 and the denominator is constantly a naught, and the sign is not altering for the first 3 terms, it is keeping minus minus minus, and for the final term it is plus. So, you can easily remember this. So, alpha plus beta plus gamma plus delta is minus a1 upon a naught, alpha plus beta gamma plus delta into alpha beta into gamma delta, then it will turn out to be this entity. Similarly, you can go for alpha beta into gamma plus delta, gamma delta into alpha plus beta, that is minus of a3 upon a naught, and alpha beta gamma delta, that is the product of all 4 roots is a4 upon a naught. So, I hope you understood that how to remember that what the formula should be all about, and this is just a simple way to remember, just to cram what the formulas are about, and we are going to apply these formulas into solve some numericals, and you will be able to better understand by applying these formulas into the numericals. Likewise, over here there is an example wherein we are supposed to solve the equation 2x cube minus 15x square plus 37x minus 30 is equal to 0. If the roots of the equation are in arithmetic progression AP. What is an AP? The roots are the terms are A plus D, A plus 2D. I hope you remember when we discussed about arithmetic progression. In the beginning, I told that the units are interconnected. The understanding of one unit will be applicable onto the other unit. So, you cannot skip any of the unit untouched, because that will be extended to the subsequent unit. Over here, if you are not aware of arithmetic progression, then you will not be able to solve this problem, because the arithmetic progression is a progression wherein there is a common difference. In between these two terms, the common difference is D. In these two terms, there is a common difference which is equal to D, and which is added to the respective term to get the subsequent term. So, there is a standard mechanism that if it is given that the terms are in AP, then the roots you are supposed to take is alpha, say alpha and beta are the roots, alpha, beta are the roots, and roots are in AP. Say there are because this is a cubic equation, so there should be 3 roots. So, the roots should be alpha minus beta, alpha and alpha plus beta. So, these are the 3 roots, and that means the sum of the roots. What was the formula for the sum of the roots? Alpha plus beta plus gamma is minus of A1 upon A naught. If this is a cubic equation having the roots alpha, beta, gamma, then sum of the roots. That means if we say this is first root, so alpha matlab you can say A plus B plus C. So, A is nothing but alpha minus beta, B is say alpha, and C is say gamma, or you can say this is A minus D and this is A or A plus D. Now, these terms are in arithmetic progression. So, sum of the terms, that is alpha minus beta plus alpha plus beta, is equal to minus of A1 upon A naught. What is A1? Value of A1 is coefficient of x square. Coefficient of x square is minus 15. So, minus of minus 15 is 15 by A naught, coefficient of x cube, that is A naught is 2. So, this turns out to be 15 by 2. So, on the left hand side, beta will be cancelled with minus beta. So, we will be having answer as 3 alpha is equal to 15 by 2, and this implies alpha is equal to 15 by 2 into 3, and 3 will cancel out to solve this, and you will get alpha is equal to 5 by 2 is equal to 5 by 2. So, I hope you understood how we applied this identity and we got the first expression, that is alpha. Now, our next task is to determine beta, because then only we will be able to determine alpha minus beta, alpha and alpha plus beta, because these roots are in arithmetic progression. We already determined alpha, and alpha turns out to be 5 by 2. Now, applying this identity alpha beta plus beta gamma plus gamma alpha, you will get the expression alpha into alpha minus beta, alpha into alpha plus beta, alpha minus beta into alpha plus beta, and that is A2 upon A2 A naught. What is A2? A2 is the coefficient of x. What is the coefficient of x? 37. And A naught is coefficient of x cube. So, 2 is coefficient of x cube. So, A2 upon A naught turns out to be 37 by 2. Now, solving opening all the braces and solving, you will get the expression which is 3 alpha square minus beta square is equal to 37 by 2. Again, that is 25 by 4, and substituting alpha square over here, you will get the answer beta is equal to 1 by 4. Beta square is equal to 1 by 4. Now, because beta square is equal to 1 by 4, so beta will be square root of 1 by 4. So, beta square root of 1 by 4 turns out that beta is equal to plus minus 1 by 2. So, we are having both alpha and beta. So, we can calculate the values of the roots which are in arithmetic progression, that means alpha minus beta, alpha and alpha plus beta. Now, when beta is equal to 1 by 2, there are two values plus 1 by 2 and minus 1 by 2. When beta is plus 1 by 2, then alpha minus beta will be equal to 5 by 2 minus 1 by 2. Alpha, that is 5 by 2, alpha plus beta, that is equal to 5 by 2 plus 1 by 2. Solving this, you will get there are 3 roots, 2, 5 by 2 and 3, because 5 by 2 plus 1 by 2 will be 2 into 5 plus 1, that is 6 by 2, that is nothing but 3. So, there are 3 roots, and on the same lines, when beta is equal to minus 1 by 2, then you will see that the 3 roots, that is alpha minus beta, alpha and alpha plus beta will be turning out to be 3, 5 by 2 and 2. Now, this is the situation, and you can easily check that these are the roots of the equation. How you can check that these are the roots of the equation or not? By substituting any of the values. Say we are over here, say substitute x is equal to 2 into this equation, and we check whether the result turns out to be 0 or not. Let us check it. So, substituting x is equal to 2, that is this value, into this equation, then we will be having 2 into 2 cube minus 15 into 2 square plus 37 into 2 minus 30, and this should turn out to be 0. Now, 2 to the 4 to the 8 to the 16 minus 15 into 4 is 60 plus 74 minus 30. So, that means 16 plus 74, 16 plus 74 is 90, and minus 60 minus 30 is minus 90, and this is 0. So, that means we are already checked that these are the roots of equation 1. So, 2 is one of the root, because this is satisfying this equation. After substituting the value 2 into this equation, we are getting the answer as 0. You can check by substituting the value 3 for x, you can check for by substituting the value 5 by 2 for x, and you will find that after substitution of the values into this equation for x, this result turns out to be 0. So, this is how you can check whether your solution is correct or not. Now, we extend our discussion by solving one more problem. Say in this case, we are given a problem, if roots of ax cube plus bx square plus cx plus d is equal to 0 are in AP, then show that 2b cube minus 9abc plus 27a square d is equal to 0. Now, because in the last question also we had given you the advice that if the roots are in AP, then maintain the common difference. So, alpha minus beta, alpha and alpha plus beta are maintaining a common difference of beta, So, that means the roots alpha minus beta, alpha and alpha plus beta are in arithmetic progression, and by following these identities, which we had already discussed, that appears to be for the roots of the cubic equation a naught x cube plus a1 x square plus a2 x plus a3 x 0 is equal to 0, where a naught is not equal to 0, then these 3 identities are followed. Applying the first identity, that is alpha plus beta plus gamma is equal to minus of a1 upon a naught. So, what is alpha, what is beta and what is gamma over here? Alpha, beta, gamma are respectively alpha minus beta, alpha and alpha plus beta. So, adding them all, alpha minus beta plus alpha plus beta, and this is to be equal to minus of a1 upon a naught. What is a1? a1 is coefficient of x square. So, over here the coefficient of x square is b, and a naught is coefficient of x cube and coefficient of x cube is a. So, this should be minus of b by a. So, adding these roots, you will find that beta will be cancelled with minus beta. So, you are getting the answer 3 alpha is equal to minus of b by a. That means alpha is equal to minus of b by 3a. So, we got the first part, that is alpha part, and that is minus b by 3a. Now, our next task is to solve for the beta, because in arithmetic progression the roots are alpha minus beta, alpha and alpha plus beta. So, applying the same thing over here, that means alpha, as we did it in our last session. So, using the formula, that is alpha, this one of the roots is alpha, that is minus b by a. Now, we are supposed to show that this is the ultimate outcome of this cubic equation if the roots are in AP, and one of the root is alpha. So, alpha should satisfy this cubic equation. So, that means, as in the earlier question, what we did in the earlier question, we substituted value 2 and value 3 into the equation to verify that whether it is turning out to be 0 or not. So, on the same lines, because alpha is one of the roots, in place of x, we substitute the value of alpha in this equation. Substituting the value of alpha in this equation, what you will be getting? A into, just watch this equation and this equation. So, a into minus b by 3a whole cube. So, we are substituting alpha in place of x over here, alpha in place of x over here, alpha in place of x over here, and d, that is alpha to the power 0 is to be there. So, alpha x to the power 1, x to the power 2, x to the power 3. So, alpha to the power 3 is minus b by 3a to the power 3. Alpha square, that is x square, is minus b by 3a whole square, and x, that is alpha to the power 1, that is minus b by 3a, and you can say that minus b by 3a to the power 0, which is turning out to be only 1. So, substituting the value of alpha in place of x in this equation, because alpha is one of the roots, you will get this as the final expression after opening the braces. Now, after opening the braces, you will get minus b cube upon 27a square, because 3 3 the 9, 3 is 27, 3 3 the 9, so 9a square, and only 3 is there, so this will be there. Now, after simplifying this equation, you will get the expression minus b cube plus 3b cube minus 9abc plus 27a square d. Now, b cube and minus b cube, two terms are there, so they will simplify to 2b cube, and what we are getting is 2b cube minus 9abc plus 27a square d, which is our required expression. Let me repeat for your better understanding again that what we had done over here, the question was that if the roots of the cubic equation are in AP, show that 2b cube minus 9abc plus 27a square d is equal to 0. And because they are in AP, so we assumed that alpha minus beta, alpha and alpha plus beta are the three roots. So, we followed the first identity, wherein we found that alpha minus beta plus alpha plus beta, and that turns out to be minus of a1 upon a naught, which is nothing but minus of b upon a. And solving, we find that 3 alpha is equal to minus b upon a, that means alpha is equal to minus b upon 3a. And alpha is one of the roots of this cubic equation. So, that means this alpha should satisfy this cubic equation. So, in order to that this alpha should satisfy this cubic equation, just substitute the value of alpha in place of x in this cubic equation, which is given to us, that is ax cube plus bx square plus cx plus d is equal to 0. By substituting the value of alpha in this cubic equation in place of x, you will get this expression, and by solving this expression you will get that this final thing which is to be proved, that we need to show that 2b cube minus 9abc plus 27a square d is equal to 0 is satisfied. I hope you understood what we did in this numerical. Now, for better understanding, let me extend and let me give you one more example. If alpha, beta, gamma be the roots of the equation x cube minus px square plus qx minus gamma is equal to 0, find the value of alpha square plus beta square plus gamma square. Mind it, again it is a cubic equation and we are having, say, just these three identities. Now, alpha plus beta plus gamma, alpha plus beta plus gamma is equal to minus of a1 upon a0. And what is minus of a1? Minus of a1, the coefficient a1 is coefficient of x square, which is minus p, and coefficient of and a0 is coefficient of x cube, which is nothing but 1. So, minus of a1 upon a0 will be equal to minus of minus p upon 1, that is equal to p. So, this is how we come to this conclusion that alpha plus beta plus gamma is nothing but p. Thereafter, alpha beta plus beta gamma plus gamma alpha is nothing but a2 upon a0. What is a2? a2 is the coefficient of x. Over here in the given equation, the coefficient of x is q, and coefficient of x cube is a0, and coefficient of x cube in the given equation is nothing but 1. So, that means this is nothing but q by 1, which is nothing but q. So, on the same lines, alpha beta gamma is minus of a3 by a0. What is a3? a3 is nothing but the constant term. In this, the constant term is gamma, that is minus gamma. So, that means minus of a3 by a0 is minus of minus gamma upon 1, that is equal to gamma. So, this is, we are getting three solutions, they are on the basis of the three identities which are discussed over here. Now, we are supposed to find the value of alpha square plus beta square plus gamma square. So, alpha square plus beta square plus gamma square is nothing but, we all know that alpha plus beta plus gamma whole square, this is equal to alpha square plus beta square plus gamma square plus 2 alpha beta plus beta gamma plus gamma del alpha plus gamma alpha. This is a well known identity. Using this identity and rearranging this identity, you get this expression, that is alpha square plus beta square plus gamma square is equal to alpha plus beta plus gamma whole square minus twice of alpha beta plus beta gamma plus gamma alpha. And we know that alpha beta plus beta gamma plus gamma alpha is nothing but q, and alpha plus beta plus gamma is nothing but p. So, this equation turns out to be p square minus 2q. This is p square minus 2q. So, we found the value of alpha square plus beta square plus gamma square by using these identities. Similarly, we can solve this numerical, that solve the equation. Now, instead of arithmetic progression, we may have the roots in the harmonic progression, and harmonic progression, as you know, that is inverse of arithmetic progression. That means, if alpha minus beta, alpha and alpha plus beta are the roots in arithmetic progression, then 1 over alpha minus beta, 1 over alpha and 1 over alpha plus beta are the roots in the harmonic progression. So, this is for the arithmetic progression and this is for the harmonic progression. I again suggest you that please go through your past sessions so as to remember and recall the concepts, and the self learning material, the components are interrelated. if you know, if you are not aware of arithmetic progression and the harmonic progression or the geometric progression, then you may not be able to solve such type of numericals. So, we learned that if alpha minus beta, alpha and alpha plus beta are the roots in arithmetic progression, then 1 over alpha minus beta, 1 over alpha and 1 over alpha plus beta are the roots in the harmonic progression, So, applying the same identity again, the first identity was alpha plus beta plus gamma should be minus of a1 upon a0, because the roots are now in harmonic progression HP. So, that is 1 upon alpha minus beta plus 1 over alpha plus 1 over alpha plus beta should be equal to minus of a1 upon a0. What is a1? a1 is coefficient of x square, and over here the coefficient of x square is minus 11. So, minus of minus 11 is 11, and a0 is nothing but coefficient of x cube, which is nothing but 6. So, minus of minus 11 by 6, that is, it is turning out to be 11 by 6. So, that means that the first solution is 1 over, for first identity it is 1 over alpha minus beta plus 1 over alpha plus 1 over alpha plus beta, turning out to be 11 by 6. On the same lines, if we solve for alpha beta plus beta gamma plus gamma alpha, you substitute the values into this identity, and the outcome should be equal to a2 upon a0. What is a2? a2 is coefficient of x. In the given equation, coefficient of x is minus of 3. So, minus of minus 3. So, the coefficient is minus 3. So, a2 is minus 3 and a0 is 6. So, as a result of which the answer will be minus 1 by 2. Similarly, the third identity, last identity, says that alpha beta gamma should be equal to minus a3 by a0. And what is a3? a3 is nothing but the constant term of the cubic equation, and the constant term over here is 2. So, minus of a3 upon a0. So, this is nothing but a3 minus of a3 upon a0, which is 6. Solving minus 2 upon 6, you will get the answer minus 1 upon 3. Now, from this equation, from the equation number 3, which is about alpha beta plus beta gamma plus gamma alpha, you will find that solving this equation, you will find that it turns out to be this much, that is alpha plus alpha minus beta upon alpha minus beta into alpha plus beta. Solving, beta part will cancel, you will get 3 alpha, and you will finally get the answer 3 alpha is equal to 3 by 2, and wherein alpha turns out to be, because 3 alpha turns out to be 3 by 2, as a result of which we will be getting alpha is equal to 1 by 2. So, this was all about this. Now, in this expression, we had substituted alpha minus beta into alpha plus beta by following equation number 4. So, let me explicitly solve it for you, just for your better understanding that how we solved it. Now, rearranging the equation number 3, it turns out to be this much. Now, in the numerator, beta will be cancelled, so we will be remaining with 3 alpha, and in the denominator we are having alpha minus beta into alpha plus beta. So, 1 over alpha minus beta into alpha plus beta turning out to be minus of 1 by 3. So, that means this is equal to minus of 1 by 3 into minus of 1 by 2. So, that means by solving you will get 3 alpha is equal to 3 by 2, and this means that alpha is equal to 1 by 2. So, referring to equation number 4, the product alpha minus beta into alpha plus beta will turn out to be minus of 3, and this is equivalent to minus of 1 by 2, because this is equivalent to minus of 1 by 2. So, that means 3 alpha, taking this over here, is 3 by 2. This implies alpha is equal to 3 by 2 into 3, that is 1 by 2. So, we evaluated for the first term, that is alpha. Now, substituting the value of alpha into the we need to find beta also. So, we are having the roots, alpha minus beta, alpha and alpha plus beta. So, substituting the value alpha 1 by 2 over here, you will get the 3 roots are 1 by 2 minus beta, 1 by 2 and 1 by 2 plus beta, and their entire result, because by equation number 4, is turning out to be minus 3. By equation number 4, we are saying that alpha minus beta into alpha plus beta, that turns out to be minus 3, and as a result of which we are getting the solution that beta is equal to plus minus 5 by 2. That means we are beta is having two values, 5 by 2 and minus 5 by 2. Substituting the value for beta is equal to 5 by 2, we will get 3 roots from the equation, from the roots alpha minus beta, alpha and alpha plus beta, and those roots are minus 1 by 2, 2 and 1 by 3. And similarly, when beta is equal to minus 5 by 2, we will get the roots separately in the reverse order. I hope you understood how to use the identities in solving the cubic equation, given the roots are in say arithmetic progression or geometric progression, and we had solved ample number of numericals. By just solving these numericals, you will be having a better grasp onto the concepts of the cubic equation and the biquadratic equations also. We left the concept of the biquadratic equation for you to exercise at your place, because the same thing are applicable when we are solving the biquadratic equation. Just for your better understanding, we solved the cubic equation in this session, and I advise you to follow the self-learning material along with these sessions for better understanding. Thank you.